So today's notes are solving systems of linear equations using all methods. So it's pretty much just a recap of the methods that we've learned so far. First we learned graphing, then we learned substitution, then we learned elimination. So we're not going to graph today, but we are going to kind of compare substitution and elimination with these examples. So example 1, solve the system of linear equations using the method of your choice. If we look at A, our system is 3x plus y equals -9. And y equals 5x plus 7. So when we're deciding between substitution and elimination, if I want to go the substitution route, I'm looking for an equation that's already solved for a variable. And that means that the variable is on its own side of the equal sign by itself, like this y is. If I want to use elimination, I'm looking more for variables that have matching coefficients and equations that are more lined up. And you can see this equation isn't lined up very well. It's the different variables are lined up together. It's kind of mixed. The equation or the equal signs aren't in the same spot. So this wouldn't be a great one to use elimination on, but we can use substitution on it. So because this second equation is already solved for y, it has y by itself, I can take this 5x plus 7 that I'm saying y is equal to, and I can substitute it into the first equation where y is. So I'm going to replace the y in the first equation with the 5x plus 7. So the first equation, everything else stays the same. So 3x plus, that comes first. And then instead of y, it'll be plus 5x plus 7. And then equals, after what was originally the y, -9. And then now in my equation, I only have x. I don't have any y's, so I'm able to solve for x. So the first thing that I want to do is, before I start like adding or subtracting to each side, I want to make sure that each side of the equation is simplified. And if I look at the left side has some like terms that I can combine. I can combine the 3x and the 5x. I combine them by adding. So 3x plus 5x is 8x. And then I bring down the plus 7 and bring down the equals -9. So now I have 8x plus 7 equals -9. So if I want to solve for x, I now have to undo the things that are being done to it. So I have an 8 that's being multiplied by x and a 7 that's being added. So I'm going to undo adding 7 by subtracting 7 from both sides. So I'll bring down the 8x, 7 minus 7 cancels out. And then -9 minus 7, so I'm starting at -9 and going down 7 more. So I end up at -16. And then now I have 8 times x equals -16, so to undo multiplying by 8, I'm going to divide both sides by 8. 8 divided by 8 cancels out. I'm left with just x equals, and then -16 divided by +8, that's a -2. So we figured out what x is. Now we can use that x to help us figure out what y is. So I can take that x and I can plug it into one of the two original equations. It doesn't matter which one, so just pick the one that you feel like is easier for you. I feel like the second one is going to be easier because it already has like y by itself. So when we go to solve and simplify, it'll be a little bit faster. So I'm going to rewrite this equation just on this side. So y equals 5x plus 7. And then since I'm saying x is equal to -2, I can take that -2 and plug it in the equation where x is. So everything else stays the same. Y equals 5 times x becomes 5 times -2. Plus 7. And then now I'll follow order of operations to simplify. So y equals 5 times -2. So that's -10 plus 7. And then y equals -10 plus 7. So I might have said this was -7 before. Sorry if I did, but 5 times -2 is -10, and then plus 7. Negative 10 plus 7, I'm starting at negative 10 and then going up 7. So I end up at negative 3. So y equals negative 3, and then we just want to write our final answer as a point, x comma y. So negative 2 was my x value. So negative 2 comma negative 3 was my y value. So altogether negative 2, negative 3. So with A, it made more sense to use substitution because we already had one equation solved for a variable. So we could just take that equation and plug it into the other. If we look at B, we have 9x minus 2y equals 34 and 5x plus 2y equals negative 16. So neither of these two equations have a variable like by itself completely like this y was. So substitution probably isn't a great option for this system. But if I look at the y's have matching coefficients. So it's going to be pretty easy to either add or subtract the equations together to eliminate it. So we'll use elimination. And then when I'm deciding whether or not I should add or subtract, I need to think if I add negative 2y plus 2y, is that going to cancel out, or do I need to subtract them? So since negative 2y plus a positive 2y is 0, I can go ahead and add the equation. Kind of just the rule of thumb is if the signs are the opposite, then you're able to add, but if the signs are the same, both positive or both negative, you'll have to subtract. So we'll go just from left to right and add each one. 9x plus 5x, that's 14x. Negative 2y plus a positive 2y, that's 0, so those just cancel out. And then 34 plus a negative 6, that's just like 34 minus 6, so that ends up being 28. And then now I have the equation 14x equals 28, so if I want to solve for x, I need to undo multiplying by 14. So I'm going to divide both sides by 14. So 14 divided by 14 cancels out. And then I'm just left with the x equals 28 divided by 14 is 2. So I have x equals 2. Now that I have x equals 2, I can use that x to find y. Just have to plug it into one of the original equations. So I'm going to use the second one. So I'm going to rewrite it up here. 5x plus 2y equals negative 6. But we just found out that x is equal to 2. So I'm going to put 2 in that equation where x is. Instead of 5 times x, it becomes 5 times 2 plus 2y equals negative 6. Then we can multiply 5 times 2. So that's 10 plus 2y equals negative 6. And then now I need to solve for y, so I need to undo the things that are being done. So to undo, I have a 10 that's being added and a 2 that's being multiplied. So I'm going to undo the addition first. So in order to cancel out this positive 10, I'm going to subtract 10 from both sides. 10 minus 10 cancels out. And then I'll bring down the 2y equals negative 6 minus 10. So I'm starting at negative 6 and then going down 10. So I end up at negative 16. Now I just have a 2 that's being multiplied by y, so I need to divide both sides by 2. Two divided by 2 cancels out. I'm just left with y equals, and then a negative 16 divided by a positive 2, that's negative 8. So y equals negative 8, and then just remember to write your final answer as a point, x comma y. So x was 2, comma, and then y was negative 8. So for B, it made more sense for us to use elimination because these equations weren't already solved for a variable, and we can easily add the equations together in order to eliminate y. For C, so we have x plus 6y equals 28, and 2x minus 3y equals negative 19. If you really prefer the substitution method, this would not be a bad one to use substitution for. So we're going to use elimination, but if you wanted to use substitution, because this is just a 1x, you could easily solve this equation for x. You would just have to subtract the 6y over, and then x would be by itself, and you'd be able to plug the equation in for x. I'm going to use elimination just because I think it's a little bit easier to follow. So, however, if I want to use elimination, right now I don't have any matching coefficients, but we can create them. So I can either take the first equation and multiply it by a 2, and then this 2x will match up with this 2x, or I can take the second equation and multiply it by 2, and then this 3y will match up with this 6y. Since these signs are the opposite, I think I'm going to eliminate y because it'll make it a little bit easier. I can just add the equations together because the signs are the opposite. So if I want to eliminate y, I'm going to take the second equation and multiply a 2 throughout it because I want this negative 3y to become a negative 6y. So we'll distribute the 2 in. So 2 times 2x, that's 4x. 2 times negative 6y, 2 times negative 3y, that becomes negative 6y. And then 2 times negative 19, that becomes negative 38. And then the first equation is going to stay the same, so we're just going to write it over the top. So x plus 6y equals 28. And then because we chose to multiply the second equation, I now have a positive 6y and a negative 6y. So if I add those two together, the y's will cancel out. So I'm going to add the two equations together. So this is like a 1x. So 1x plus 4x is 5x. 6y plus negative 6y, that cancels out, that's 0. And then 28 plus a negative 28. So if I start at 28 and then I go down 38, I end up at negative 10. So 5x equals negative 10. Now I just need to divide both sides by 5. Five divided by 5 cancels out, so we're just left with x equals, and then negative 10 divided by a positive 5 becomes negative 2. And then we have x, so we can use our x to help us find y. Pick one of the original equations to plug x in order to figure out what y is. I'm going to use the first one. Looks a little bit easier. I'm going to rewrite it over here. X plus 6y equals 28. And then we figured out that x equals negative 2, so that negative 2 is going to get plugged in for x. So instead of x plus, it becomes negative 2 plus 6y equals 28. So now I want to solve for y. I got to undo the things that are being done to it. So I have a negative 2 that's being added and a 6 that's being multiplied. So I can cancel out this negative 2 by adding 2 to both sides. Negative 2 plus 2 is 0, so that cancels out. I need to bring down the 6y. And then 28 plus 2, that's 30. So 6y equals 30 is my new equation. I want to cancel out multiplying by 6, so I can do so by dividing both sides by 6. Six divided by 6 cancels out. I'm left with y equals, and then 30 divided by 6, that's 5. So then just remember to write your points all together. So x comma y, our x was -2. And then our y was 5. So -2 comma 5.